Good evening, dear students. Yes, after a very long time, we all have met for the KCT classes. Yes, so already we have completed the theory portion, right? So the first chapter which I'm going to start is solutions. Okay, so we are going to see the MCQs. Okay, so for your CET, that is your the common entrance test. Okay, which is conducted okay after your board exams so that you so that is the exam okay which is a criteria for eligibility okay for engineering pharmacy right so and so other courses so this is a compulsory exam okay which you have to attend okay fine so, as you know, in chemistry, you have 10 chapters, okay, so which we have completed in our ACE program, okay, so all the theory and I have discussed, okay, so that is for your board exams, okay, for your board exam point of view. So, what all are the important things, what type of questions are asked. So, these all things we have discussed there, right? So here, what all things we are going to discuss in our CET sessions. Okay, we are going to discuss the types of questions which are asked. Okay, what type of questions are asked, which are the repeatedly asked questions. Okay, what type of questions are asked for your KCET. So these are all things we are going to discuss. Okay, we are not going to we are going to focus on the important things. Okay, so here we are not going to start with the synopsis means short this so those notes will be sent for you all okay synopsis means how the like what are the important points from that particular chapter. So in this particular chapter, solutions, right? So already we know what are solutions, okay, what are the types of solutions. So these all things we have discussed. So what all things we have discussed again? So we have discussed about expressing the concentrations of the solutions. So different concentration terms we have discussed like your mass percentage, volume percentage, right? Then mass by volume percentage, then parts per million, that is your ppm. Then we have discussed about molality, normality, mole fraction, right? So these are all the important concentration terms. Okay, so these all things, the formulas are important. Okay, so these using this formula, we are going to find the concentrations. Okay, of the different solutions. Fine. Then we have discussed about something. Okay, called as the solubility. Okay, different. We have discussed about the solubility of solids in liquid. Right. Then gases in liquid and their effects. Okay, the different effects like a effect of temperature, pressure. Then we have discussed something called as Henry's law. Right. Everything you might have gone through. Okay, so the students who have missed those sessions can go through the YouTube okay page and there you can search for this videos okay for this ACE program whatever we have done so those videos will be available there. So then we have discussed about the application of Henry's law, right? Then we have discussed something called as Rawls law, right? Then we have discussed something called as the Rawls law. Then the ideal solutions, non-ideal solutions, right? Then we have discussed something called as azeotropes, right? Azeotropes, colligative properties, very important. So based on colligative properties also, you will be getting questions. So colligative properties, four important colligative properties, that is relative lowering of vapor pressure. Then you have elevation of boiling point, right? Then you have depression in freezing point and the last one is your osmosis, right? The last one is osmosis. So, so these are the important things. Then we have discussed something called as isotonic, hypertonic, hypotonic solutions. Okay, reverse osmosis, osmotic pressure, right? Then Van 't Hoff factor. So these are all the things which we have discussed. Okay, so based on these important concepts, okay, let us start with the MCQs. Okay, so let us start with the MCQs. So this is the first question. The first question is, which of the following can be measured by A, vapor pressure of the solvent, B, relative lowering of vapor pressure, C, lowering of vapor pressure, and D, all of this above. Yes. So what we have discussed in colligative properties, which are the four important colligative properties which we have studied? Yes. Can you answer this? So you can use the chat box, or else you can also unmute yourself. Okay, I'll give you that option. So you can unmute yourself, or you can use the chat box and you can give the answer A, B, C, and D. So these are the four options. So which answer you feel okay? So there is a method called as Oswald-Walker dynamic method. Okay. So where this method is used? Where this method is used. So, so what we do in this Oswald-Walker dynamic method, okay? So it is based, okay,
B, ma'am.
C.
B, relative lowering of vapor pressure.
Okay, fine. Okay, one girl has answered it as B. Fine. So before that, let me tell you Oswald-Walker dynamic method. Okay. So here, what is this method? It is based on the principle that you have successful tubes. Okay, you have a successive tubes. Means what? Side to side tubes are there. Okay, and you're passing dry air through it. What you're passing? You're passing dry air through it, through this series of containers. Okay, and these series of containers, it contains solution as well as the pure solvent. Okay, and then what is done after this air? Okay, after it is passed, it gets saturated. What do you mean by saturated? It gets concentrated. Okay, it gets concentrated with the solvent vapors. Okay, so so like this. So this is the method. Okay, so what we are going to do, we are having these tubes. This consists of solution as well as the solvent. So after you pass the dry air, so the solvent vapors gets concentrated at the below. Okay, and what happens here? So equal amount of, this is because the tube is connected, right? So equal amount of solvent vapors are saturated at bottom. Okay. This particular method, it is used for your relative lowering of vapor pressure, right? So we know that in solutions, okay, we are what we are in colligative properties, okay, it depends upon the number of solvent particles, right? So here, so when we are discussing that the saturated part, okay, it is nothing but the solvent vapors, they are saturated. So it tells you what it measures about the relative lowering of vapor pressure. So yes, P is the answer. Very good. So Suraya has answered, Sri Varuni has answered. Okay, so others can also answer. Okay, if it is wrong, no problem. So you have to try. Okay, you are trying. You are not giving the exam here. So you are in the study process, right? You are studying something. You are studying something. So you are in the studying process. So don't shy. Okay, so you have to answer. Let it be wrong. Let it be correct. So you have to. Participation is important here. Okay, fine. So let us go with the second question. So this is my second question. Okay, so vapor pressure of pure A is 70 mm of Hg at 25 degrees Celsius. It forms an ideal solution with B in which mole fraction of A is 0.8. If the vapor pressure of the solution is 84 mm of Hg at 25 degrees Celsius, the vapor pressure of pure B at 25 degrees Celsius is A 56 mm, B 70 mm, C 140 mm, and D 28 mm. Okay, Suraya has answered it as C. Baby has answered it as A. Lubna has answered it as A. Okay. So what all are the given things? So this is based on the vapor pressure. Okay. So here, what all things are given? So the vapor pressure of pure solvent A, it is given as 70 mm. Okay, 70 mm of He. Then it forms an ideal solution with B. Okay, so you have to find the vapor pressure of B and what it mole fraction of A is given, right? Mole fraction of A, it is given as 0.8. And if the vapor pressure of the solution is 84 mm. Okay, so vapor pressure of the solution is given as 84 mm. So you have to find the vapor pressure of B. So now we know that. Okay, so what all things? So what all things we know? So we know that according to Raoult's law. Okay, according to Raoult's law, what is the law? So P is equals to P naught of A into mole fraction of A. So plus P naught of B into XB. Okay, so how to find the mole fraction of B is not given. So we know that XA plus XB, okay, that is your mole fraction of number of moles of A plus mole fraction of B is equals to total is 1. So A is what? 0.8 plus this is equals to 1. So it is B is equals to 1 minus 0.8. It is 0.2. Okay, so we got the mole fraction of P. Now, according to this formula, so let us put the values. So P naught of A is what? What is P naught of A? 70. Okay, into psi of A is 0.8 plus this we have to find out. Okay, and psi of B is 0.2. Total pressure is how much? It is 84. Okay, find out now. Find out. So what you have to do? Okay, so find out. So 70 into 0.8. How much you are going to get? So simple calculation, right? So do it now. Whoever has not got. So 70 into 0.8 is 56 plus. Okay.
1.2.
Okay. So psi naught of B is equals to 28 divided by 0.2. Just see how much you are going to get. So this 56 when it comes here, so it becomes 84
140, ma'am.
minus 56. Okay, so here 84, so it becomes 84 minus 56. Okay, equals to sine naught of B into 0.2. So this becomes 28. This becomes divided by 0.2 like this. Okay, so for easy. So it is 140 mm. Are you getting the same, everybody? So I got C as the option. Yes, Shivaruni. Yes, Lubna. Yes, correct. Okay, everybody got it? Is it correct? Are you getting the questions? Any confusion? If you want me to repeat it again, I'll repeat. I have done it stepwise. Okay, step one, stepwise I have solved. Okay. So let us proceed for the next question, I suppose. So last question, this was asked in 2008 paper. Okay, the first question. And this particular question was asked in 2009. Okay. So fine. So let us go for the next particular question. A 6% solution of urea is isotonic with A 0.05 molar solution of glucose, B 6% solution of glucose, C 25% solution of glucose, D 1 molar solution of glucose. a 6% solution of urea is isotonic with? Can anybody tell me what do you mean by isotonic? Yes, isotonic. What do you mean by isotonic? Okay, so Iraya has answered it as D. Lubna has also answered it as D. What do you mean by isotonic? Isotonic solutions are those solutions which have same concentration. Okay, when we have same concentration, then it is said to be isotonic. So here we have a 6% solution of urea. Okay, so they have asked it is isotonic with what? Okay, so now 6% of urea. 6% of urea. Okay, so isotonic means same concentration, same molar concentration. Solutions having same molar concentration. Okay, so 6% of urea means what? It means 6 grams of urea, okay, in 100 ml solution. Okay, so what is the meaning of the word 6% of urea? It means 6 grams of urea. Okay, it is dissolved in 100 ml of solution. Fine. So let us calculate the moles of solute. So which is our solute? Urea is the solute. Okay, so how do you calculate the number of moles? Given weight upon the molecular weight. What is a given weight? Given weight is 6 grams. What is the molecular weight of urea? It is 60. Okay. Molecular weight of urea is what? It is 60. Fine. So, in mole. So, the number of moles of solute is 0.1. Fine. How much is volume of solution? 100 ml. Right. It is dissolved in 100. Okay. So, it will be 0.1. So, whenever ml is there, okay. So, if you convert, if you multiply it by 1000. So, just to see. So, 100 divided by 1000. Okay. So, it will be what we have done, we have divided by 1000. So, we get 0.1 liter. So, we are converting ml into liter. Okay, we are converting ml into liters. So what is molarity, students? What is molarity? Molarity is number of moles of solute upon volume of solution. So what is the number of moles of solute? It is 0.1 molar, right? And what is the amount of solution? Volume of solution is 0.1 liter. So what is molarity? The molarity is 1 molar. Okay, so therefore 6% of solution of urea, it is isotonic with 1 molar of solution of glucose. Yes, option number D is correct. Okay, any doubts here? Did you understand? So like this are the questions. Okay, so everything is given. Okay, so here, okay, how this 60 comes, if you have the doubt how this 60 came. So NH2C double bond over NH2. So this is a molecular formula of your urea. So if you calculate, nitrogen is as 14 into 2 nitrogens. Then hydrogens are 1 into 2. Then carbon is 12 into 1. And oxygen is 16 into 1. So if you calculate, 4 by 8, 2 ones are 2, 2, 12, and 16. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 18. Okay, 4 hydrogens are there, sorry. 4 hydrogens are there, so it becomes 60. Okay, so like this. So number of, that is moles of solute is calculated as given weight upon molecular mass or molar mass. Okay. So molar mass of urea is 60 and given is 6 grams. Is it clear? Any doubts? Are these 3 questions clear? Any doubts up to here? Anything you want me to repeat? No. Okay, fine. Okay, so
ಮ್ಯಾಮ್
yeah.
ಇದು ನನ್ನ ವೇಪರ್ ಪ್ರೆಷರ್ ಪಿ ನಾಟ್ ಎ ಬರ್ತಾರೆ, ಪಿ ನಾಟ್ ಬಿ, ಓಕೆನಾ? ಅದು 1 2 ಬರಿಬೋದಾ ಮ್ಯಾಮ್? ಎ ಟು ಎ ಅಂಡ್ ಬಿ.
ಯಾವುದು ಅದು ಪ್ರೀವಿಯಸ್ ಕ್ವೆಶ್ಚನ್?
ಹಾ ಅದು ಮ್ಯಾಮ್ ಪಿ ನಾಟ್ ಎ ಲೈಕ್ ಪಿ ನಾಟ್ ಎ ಮೈನಸ್ ಪಿ ಬಿ ಅದು
ಹಾ
1 2 ಬರಿಬೋದಾ ಎ ಜಾಗದಲ್ಲಿ 1 ಬಿ ಜಾಗದಲ್ಲಿ 2.
ಇಲ್ಲೇ ಓಕೆ ಬರಬಹುದಾ, ಬಟ್ ಇಲ್ಲೇ ನೋಡು ಇದ್ ಕೊಟ್ಟಾರ ಏನ ಎ ಬಿ ಕೊಟ್ಟಾರಲ್ಲ, ಸೊಲ್ಯೂಷನ್ಸ್ ಪ್ಯೂರ್ ಎ ಸೊಲ್ಯೂಷನ್ ಎ ಮತ್ತು ಪ್ಯೂರ್ ಸೊಲ್ಯೂಷನ್ ಬಿ ಕೊಟ್ಟಾರ. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಮೆನ್ಷನ್ ಇಟ್ ಆಸ್ ಪಿ ನಾಟ್ ಎ ಓನ್ಲಿ ಅಂಡ್ ಪಿ ನಾಟ್ ಬಿ ಓನ್ಲಿ.
ಓಕೆ
Okay, ಹೌದಲ್ಲ. So here they have asked it for pure, they have mentioned as pure A and pure B, two solutions, right? So you have to mention it for pure A and pure B. You can write 1 and 2, but confusion bad.
ಓಕೆ ಮ್ಯಾಮ್ ಥ್ಯಾಂಕ್ ಯು ಮ್ಯಾಮ್.
Okay, okay, fine. Okay, let us go for the next one. So fourth one, in countries nearer to polar region, the roads are sprinkled with calcium chloride. This is A, to minimize the snowfall, B, to minimize pollution, C, to minimize the accumulation of dust on the road, and D, to minimize the wear and tear of the roads. So in the countries which are nearer to polar region, so polar region, near polar region, what happens? So there snowfall will be more, right? There it is a colder region. So because of that, there what they do, they sprinkle calcium chloride. Okay, they sprinkle calcium chloride. So why they sprinkle this calcium chloride? In countries nearer to polar region, the roads are sprinkled with calcium chloride. Yes, why do they do? You think so? Okay. So A, okay, many have answered it as A, is to minimize the snowfall. Okay. So here, yes, correct answer is A, to minimize the snowfall. So this calcium chloride, okay, it is a non-volatile solute. Non-volatile means what, students? What do you mean by non-volatile? What do you mean by non-volatile? Volatile means what? Suppose volatile, I'll give you example of acetone, ether. Okay, your nail polish. Okay, nail polish. Sorry, nail polish remover. Okay, not nail polish. Nail polish remover. It consists of what? It consists of acetone. So if you keep open, it will easily vaporize. Okay, it will easily vaporize. So it is a volatile solute. It is called as volatile solute. So this calcium chloride, it is non-volatile. It won't vaporize. Okay, it won't vaporize. So because of that, what will happen? It results in depression in freezing point. Okay, as calcium chloride, it is a non-volatile solute. It results in depression in freezing point. So what happens because of that? Snowfall is reduced. Okay, snowfall is reduced, and what it does, it prevents the blocking of road. Okay, roads will get blocked if snowfall falls more, right? So it prevents the blocking of roads. So A is the answer, to minimize the snowfall. Okay, what they do in near the polar region, they sprinkle it with calcium chloride. Okay, fine. Let us go for the next one. The empirical formula of a non-volatile is CH2O. A solution containing 6 gram of the compound exerts the same osmotic pressure as that of 0.05 molar glucose solution at the same temperature. The molecular formula of the compound is. So the empirical formula of a non-volatile solution is given, non-electrolyte is given, sorry. It is CH2O. Okay, a solution is containing 6 gram. So what? And they are having same osmotic pressure. Okay. So when we say same osmotic solution, same osmotic pressure means what? They are isotonic, right? They are isotonic. So for isotonic solution, we know that pi is equals to CRT, right? Pi is equals to CRT. Concentration is nothing but given weight upon molecular weight. So we know that for isotonic solution, it is given as W1 upon M1 V1 is equals to W2 upon M2. Okay, this is after solving. Now, what is W1? We know that W1, we can take it as the mass of the glucose. Okay, mass of the glucose. So, W1 is the mass of the glucose, that is 0.05. So, how we can calculate the mass of the glucose into its molecular weight? Okay, so what is W1? So, 0.05 into what is the molecular molar mass of the glucose is 180. So we get it as 9 grams. Okay, we get 9 grams. Now here, what is W2? Sorry, this is W1. Then we have to find M1. What is M1? M1 is the molecular mass. Okay, M1 is the molecular mass of glucose. M1 is the molecular mass of glucose, which is 180 grams. Now, what is V1? So they say that the empirical formula solution containing exerts the same glucose solution at same temperature. So here we are assuming that V1 and V2 will be 1 liter. Okay, it is 1 liter. So same volume we have taken. Now what is W2? W2 is the second your mass of the compound, that is 6 gram. Okay, so we have to find the molecular mass of the unknown compound. So let us put these values. So W1 is what? W1 is 9 grams divided by M1 is what? 180 into V1. So 180 into V1 is 1 is equals to what is W2 is 6 grams divided by what is M2? M2 we don't know, and our V2 is 1. Okay, so solve this and see. So 9 by 180, okay, is equals to 6 by M2. So if you do cross multiplication, so M2 into 9 is equals to 6 into 180. So M2 is equals to 6 into 180 by 9. Okay, 9 ones are, 9 twos are. So just see, so 2 threes are, so it is 120 grams. So I am getting it as 120 grams. So I got the molecular mass. I got the molecular mass of M2. Okay, compound 2. What? 120. Now we need to find what? We have to find the molecular formula. Empirical formula is given. So how do you find empirical? So molecular mass divided by the empirical mass. Okay, empirical mass. So that is given as N. So N is equals to, what is molecular mass is 120 and empirical mass is how much? So carbon is, so CH2O. Carbon is 12 into, sorry, carbon is 12 plus 2 plus 16. Okay, so it is 6, 7, 8, 9, 10. So 1, 2, 3. So it is 30. 30. So how much it is? 3 ones are, 3 fours are. So N is equals to 4. So what formula we got? We got the molecular formula as your reveal, right? So molecular formula is CH2O into 4. So we get C4H4 to the 8 and O4. So it is C4H8O4. C4H8O4. Option number D. Yes, Suraya, Srivaruni, and baby. Yes, answer is correct. Yes, so it is option number D. Okay, it is option number D. So like this. So what all things? So we have two compounds. Okay, two compounds. given weight is given, molecular mass is given, volume we know. Only we have to find the molecular formula, or sorry, molecular mass of the unknown compound. So from that we are going to find the we have empirical formula also. Okay, so we have to find the molecular formula. Fine. So is it clear? Yes, Lubna has also answered it. Option number D is the correct answer. Understood? Okay. So let us go for the next question. So this was a question asked in 2010. Okay. Next question. Okay. Similar question. Okay. So here, the empirical formula of a non-electrolyte is CH2O. A solution containing 3 gram of the compound exerts the same osmotic pressure as that of the 0.05 molar solution, glucose solution. The molecular formula of the compound is. Okay. So let us see. So let us see this. Now here also we have same osmotic pressure. Okay. We have same osmotic pressure. So we are going to use, so for the isotonic solution, we have Wx upon mx. Okay, so given weight upon the molecular weight is equals to, what is the given weight? So this is, what is glucose? It is C6H12O6 upon the molecular weight of the glucose is C6H12O6. So what is weight given as 3 grams? Okay, 3 grams upon molecular weight we have to find. Okay, the molecular weight we have to find. Now what is the molecular weight of the unknown? So 0.05, okay, of glucose containing 9 grams of glucose. How? We have 0.05 into 180. So this comes to be 9 gram. Okay, this comes to be 9 gram. Then what is the molecular weight of the glucose is 180. Okay, it is 180. So mx is equals to into, so molecular weight of the unknown into 9 grams is equals to 3 into 180. So it is 3 into 180 is how much? One 80.
450, ma'am. Sorry, 540, ma'am.
540. Okay.
Yes, ma'am.
So 540 divided by 9. 540 divided by
60.
9. 60. Okay.
Yes,
So the
ma'am.
molecular weight of the unknown is 60. So we get it as 60. Now here, so the molecular weight of the electrolyte, okay, of that electrolyte is how much? So the molecular weight of electrolyte is 60. Fine. So empirical formula is what? Empirical formula is given as CH2O. Fine. So let us find the empirical formula mass. Empirical formula mass. What is empirical formula mass? 12 plus 2 plus 16. It is 30. Okay. Now we know molecular formula. What is the formula to find molecular formula? Is equals to N into empirical formula. So N is equals to molecular mass. Okay, molecular mass divided by empirical formula mass. Empirical formula mass. So what is a molecular mass is? Molecular mass is 60. Okay, molecular mass is 60 and empirical formula mass is 30. So this is
N
3 1
value is
3
2.
2. Yes. So let us find out the what molecular formula. So the molecular formula
Option B,
is
ma'am.
2
It's
into
option is C,
CH2O.
ma'am.
So that is C2. Yes, it is option number
B.
C2H4O2. Option number B. Okay, C2H4O2. So like this. Okay, so we have found the molecular formula of the compound. So it is C2H4O2. So similar problem, but a bit twist is given here. Okay, so in that previous, okay, the molecular formula only, but that was for 6 gram. So that was for 6 gram of a compound. This is for 3 grams of a compound. Okay, so you can see that difference. So here it is 6 gram, here it is 3 grams. Okay, so similar problem, this is given. What numbers are changed? So it is option number B. Okay, let us, so this was a question asked in 2011. Okay, let us go for the next one. A solution of two liquids boils at a temperature more than the boiling point of either of them. Hence, the binary solution shows A. Negative deviation from Raoult's law. B. Positive deviation from Raoult's law. C. No deviation from Raoult's law. And D. Positive or negative deviation from
It's A, ma'am.
Raoult's law depending upon the composition. Okay. Others, what about others? You can answer it. What is the answer? A solution of two liquids boils at a temperature more than the boiling point of either of them. Okay, so what are these binary solutions? What are they showing? Whether they'll show a negative deviation or positive or no deviation or positive or negative depending upon the composition. Okay, one more answer. Suraya has answered as A. So we know that solutions, they boil at a relatively higher temperature, right? Solutions always they boil at relative higher temperature. So what that means, what when they are boiled at higher temperature, meaning the vapor pressure, okay, vapor pressure of solution is less. Okay, the vapor pressure of solution will be less. So because of that, what will happen? It will show negative deviation for the Raoult's law. Okay, so option number A is the correct answer. Yes, very good. So Redmi 7A, you can update your name there. Okay. Yes, correct. Answer is correct. A is the option. So whenever any solution, okay, it is boiling at relatively higher temperature, means what will happen to the vapor pressure? Vapor pressure of the solution will be less. So therefore, it will show negative deviation from Raoult's law. Okay. Let us go for the next one. So this was a question asked again in 2011. Next question. The mass of a non-volatile solute of molar mass 40 grams per mole that should be dissolved in 114 grams of octane to lower its vapor pressure by 20% is. The mass of a non-volatile solute of molar mass 40 grams per mole that should be dissolved in 114 grams of octane to lower its vapor pressure by 20% is. So how do we solve this now? Yes, how do we solve this? So the mass of a non-volatile solute is given. So we are going to use the Raoult's law again here. Okay, so this is a question based on our Raoult's law. So what is the Raoult's law here? What we are going to use? So we know that P naught minus PS upon P naught is equals to given weight upon molecular weight. Okay, divided by given weight upon molecular weight of A upon given weight of B upon molecular weight of B. So here what is WA and MA? Okay, so this is a weight of this. solute. Okay, weight of solute and molecular mass of the solute respectively. So this is weight of solute and molecular weight. Okay, and this is molecular weight of the solute. And here WP, so here also same weight of the solute this is, and this is what? This is weight of solvent. Okay, weight of solvent, and this is molecular mass of the, or molecular weight of the solvent. Okay, and what is P naught? P naught is the vapor pressure of pure solvent. Vapor pressure of pure solvent. And what is PS? It is the vapor pressure of solution. Vapor pressure of solution. Solution means solute and solvent together are called as solution. Okay. So here, so let us put the values now. Now what all we have? So we know that the mass of a non-volatile solute of molar mass 40 grams, that should be dissolved in 114 grams of octane to lower its vapor pressure by 20% ease. Okay, so what all things are given? So, okay, Suraya has answered it as A. Shivaruni has also answered it as A. Okay, so let us solve this. So this is clear, this formula. So we are going to use this particular Raoult's law formula, that is vapor pressure of pure solvent minus vapor pressure of solution divided by the vapor pressure of the pure solvent is equals to, okay, so WA by MA divided by WA upon MA plus WB upon MB. So how we are going to use here. So I'll clear this. Okay, I'll clear this. So let us see. So here this is 40 grams per mole. Okay, and that should be dissolved in what? It should be dissolved in 114 grams of octane. Okay, and its vapor pressure will be lowered by 20%. Okay, so here let our W be the non-volatile solute which is used. So non-volatile solute. Okay, it is given as small w, and its molar mass is 40 grams per mole. Okay, so the number of moles of non-volatile solute, okay, is equals to given weight we don't know upon 40. So what is given weight? Given weight we don't know upon 40. Okay, so the number of this, so it will be W by this moles. Okay, now 114 grams of octane. Okay, so this is our so the molar mass is how much? The molar mass is 114 grams per mole. Okay, that means 114 divided by 114, that is 1 mole. It is 1 mole. So 114 grams of octane, its molar mass is 114. So given weight is also 114, molar mass is also 114. So it will be 1 mole. So the number of moles of octane, okay, our solvent is how much? 1 mole.
ಅಕ್ಕ ಈ ಸೌಂಡ ಬರ
Okay, so let us continue. Sorry for the, so there was some network issue. Okay. So P naught minus PS by P naught is equals to, so here, okay, so this is given as what? Its lower pressure is given as 20%. 20% means what? 20 by 100. Okay, 20 by 100 is nothing but 0.2. Okay, so we got P naught minus PS upon P naught. So the value is 0.2. Okay, so let us put these all values. So 0.2 is equals to, so it is WA by MA divided by WA by MA plus WB by MB. So what is 0.2? Okay, WA is, we don't know WA, so let it keep as WA. 40 is the molecular mass. Okay, then WA again we don't know. 40 is the molecular mass. Then here what is WB? So the weight, and this is same. So it is 114 by 114. Okay, so let us solve this. So I'll solve it here. Okay. So it will be 0.2 is equals to WA by 40 divided by WA plus 40 divided by 40. So this becomes 1, right? So it becomes WA plus 40 divided by 40. So it will be 0.2 is equals to WA. Okay, 40 get cancels. Okay, and it will be WA by WA plus 40. Fine. So here 0.2 is equals to what it will become. So we will just multiply it. So W A into, so it will be 0.2 into WA. Okay. Plus 0.2 into 40 is how much? Just see. 0.2.
40.8.
0.2 into that. See here, we are multiplying it, right? So 0.2 into WA will be 0.2 into WA plus 0.2 into 40. Okay, it will be how much? It will become 8 is equals to WA. So this will be a easier one. So I have taken this. So 8, let us take this side. So this will be WA minus 0.2. So we have multiplied this, right, into WA. So it is 0.8 into WA. So WA will be 10 grams. Okay. So 8. So this will go and what will it will become? 8 plus 0.2. Okay. So it will become 10 grams. So it will become 10 grams. So 8 is equals to WA minus 0.2 into WA. So it will become 0.2 into WA. So it is 10 grams. So it is option number A. Option number A. So 8 into 0.2. Sorry, 8. Okay. So option number A is the answer. Let us go for the next question. The vapor pressure of two liquids are given. Okay. Vapor pressure of two liquids are given. A and B in their pure state and with a ratio of 1:2. A binary solution of A and B contains A and B in the mole proportions of 1:2. The mole fraction of A in the vapor pressure of the solution will be. Okay, so here what is given? The vapor pressure, that is PA by PB is given. So the vapor pressure of two liquids are given, that is PA and PB. So the ratio is 1/2. Okay, 1/2. So what we have to find? We have to find the mole fraction of A, okay, in the vapor pressure of the solution. So from this, okay, so from these things, we have to find the mole fraction of A. Now here, PA by PB is equals to 1/2. So we can also do PB is equals to PB into 1 is equals to PA 2. So it is PA is equals to PB is equals to PA into 2. Right. So 2 times PA. So PB is 2 times PA. So mole fraction. So mole fraction of A in the vapor pressure in the vapor phase. Okay. So what is the mole fraction of in the vapor phase of A? So it is PA upon PA plus PB. Right. We know this. Okay. So mole fraction of A is what? Na upon Na plus Nb. Right. Whenever we are finding the mole fraction of A, it is number of moles of A upon total number of moles of A plus B. So here what we are finding? We are finding the mole fraction of A in the vapor phase. So we have to take the vapor pressure of A upon vapor pressure of A plus B. Now PA upon PA plus. What is PB? PB is 2 times PA. Okay, we'll substitute this, whatever we have got from here. So PB is what? 2 times PA. So that we have substituted. So now find out. So the vapor pressure, so it will be what? So it is 1 by, so this is 1. So PA is 1. So 1 by 3. Okay, 1 by 3 is nothing but 0.33. So the answer is coming as option number A. So what is PA? PA is 1, right? So 1 upon 1 plus 2, right? 1 upon 1 plus 2. So this is, it comes to be 1 by 3. So we are going to get 0.33. Everybody got the same? Option number A is the answer. Everybody got the same. So we know that mole fraction, okay, of A plus B, the total will be always equal to 1. Okay, total will be always equal to 1 or it will be less than 1. So this is the, it is 1. Okay, the total, this will be 1. So now PA is what? The ratio is 1. PA is also 1. So this is 2. So after putting this value, we are going to get 0.33. Are you getting the same? Yes, everybody. So I have got option number A. Option number A. Is it clear? Okay, fine. Let us go for the next one. So we have solved 9 questions. Any doubts up to here? Yes? Any doubts up to here? So, okay, let us go for the next question. Okay, let us go for the next question. Which of the following is not a colligative property? So this was a question asked in 2013. So which of the following is not a colligative property? Elevation in boiling point, depression in freezing point, osmotic pressure, lowering of vapor pressure. Yes? Which one is not the colligative property? Yes, students? Yes, Sri Varuni has answered it right. Very good. Option number D. Lowering of vapor pressure. Okay, lowering of vapor pressure is not a colligative property. It is relative lowering of vapor pressure. Okay, relative lowering of vapor pressure is a colligative property and not lowering of vapor pressure. So this is not the colligative property. It is relative lowering of vapor pressure. So please see the this correctly. Yes, Suraya has also answered it correct. So lowering of vapor pressure is not a colligative property. Relative lowering of vapor pressure is a colligative property. What is colligative property? It depends upon what? It depends upon the number of moles of solute and solvent particles. Okay. It depends on what? Number of moles of solute and solvent. Okay. It depends only upon the number of moles of solute and solvent. And independent of what? It is independent of nature of solute. It is independent of nature of solute. So remember this, okay? So small, if you see, okay, if you have not studied this properly, thoroughly, then you will get again confused because you will find that all four are colligative properties, okay? Because there is no small word that is relative. If relative, so because this small word also plays a very different meaning. Okay, so lowering of vapor pressure is not a colligative property, but relative lowering of vapor pressure is a colligative property. Why? Because colligative property depends on what? It depends upon the number of moles of solute and solvent particles, and it is independent of nature of solute. Okay, is it clear? Okay, fine. Okay, one last question. Okay, so it's, yeah. 3 grams of urea is dissolved in 45 grams of water. The relative lowering in vapor pressure is. So the relative lowering of vapor pressure is given as what? We have just now seen this is equals to N2 by N1 plus N2. Right. So for of water, the relative lowering in vapor pressure is. So your N1. Okay. So here what we have taken. So the relative for dilute solution. So when we are considering the dilute solutions, so N2 can be neglected. Okay. When you are when we are what we are considering the dilute solution, N2 can be neglected. So here we can take P naught minus Ps upon P naught is equals to N2 by N1. So this can be neglected. Okay. So let us put the values. So N2, what is number of moles of N2? It is 3. Okay. So that is urea. It is 3 by what is the molecular weight? Number of moles of urea can be given weight upon molecular weight of urea, that is 60. And what is the water? Yes, N1 is the water. So that is our solvent. So the given weight is 45 upon molecular weight of water is 18. Okay, find out the answer, students. Okay, so Raya has answered it as C. F, who is F? Please update your name. Has also answered it as C. What is the answer? Yes, C is the correct answer. Shri Varuni has also answered it as C, and C is the correct answer. So after solving this, okay, 3 by 60 into 18 by 45. So what you are going to get, just see, 3 ones are, 3 ones are, 3 5s are 15. So 3 to 18 divided by 60. Okay, 0. Yes, baby has also answered it. Very okay. So yes, option number C is the answer. Yes, Surya, 0.002, no, 0.02 only. Okay. Which of the following aqueous solution will exhibit highest boiling point? A, 0.01 molar urea, B, 0.01 molar KNO3, C, 0.01 molar Na2SO4, D, 0.015 molar C6H12O6. This was a question asked in 2013. Which is the following solution will exhibit highest boiling point? Yes. So here we have to calculate the number of ions. Okay, number of ions can be calculated as what? I into M. Okay. So here when we calculate the I into M, so urea is a non-electrolyte. Okay, non-electrolyte. So this we are not considering. C6H6O12, this is also a non-electrolyte. Now when we are considering KNO3 and this, it is a electrolyte. Okay, here. So here when we are considering these two aqueous solution, K plus and NO3 minus. So both are what? We are having the your urea, the value is 1. Okay, urea value will be 1. Number of ions here will be 1. Then KNO3 is how much? KNO3 is 2. Okay, K plus is 1 and NO3 1 is, so it is 2. And Na2SO4, so Na is plus, so there are 2 Na plus and SO4 minus. SO4 minus 2. So this is 1. So this is 3 ions. Okay. So this is 3 ions. This is 2 ions. And this is also 1. C6H12O6. Then when we are considering the I into M value. Okay. So this will be 0.01. This is 0.002. This is 0.03. So the value for C will be more. Yes, Suraya has answered it correct. So I into M of Na2SO4 is highest. Okay. So because of that, the highest boiling point will be its high boiling point will be also highest. So option number C. Yes, Sri Varuni has also answered it. Okay, is it clear? So we have solved 12 questions. Okay, we have solved 12 questions. So the remaining questions we'll be solving in the next class. Okay, any doubts, anything you want to ask or any difficulty? Yes, any suggestions or you can tell me. Anything you have not understood? Anything you want me to change? Yes. All the questions. Okay, all the questions are understood. Okay, 12 questions once again. Fine. So here, when we are calculating, so when we are calculating the boiling point, okay, they have given 4 solutions, and you have to tell which of the will have same this. Okay, so you can see the concentration here. It is same. Okay, which will show the highest boiling point. So the temperature it is shown by I into Kb into M. So this is the formula which we are going to use. That is the elevation in boiling point formula. So when we are discussing about the 4. So we have to consider the 4 number of ions. Okay, so the number of ions in urea will be 1. Okay, because urea it is a non-electrolyte. So this is also C6H12O6. So the number of this is 1. When we see KNO3 and Na2SO4, KNO3, okay, when it splits, it will split into K plus and NO3 minus. So the number of ion released will be 1 here, and this will be 1. So it will be 2. And Na2SO4, Na2SO4. So this will be how much? So Na is plus. So there are 2 Na. So it is 2 Na plus SO4 minus 2. So here 2 Na plus 1, it will be 3. So number of ions will be 3. Here it will be 2. Okay. So now when we are using this formula, so I into M. Okay. So here so when we calculate for urea, it was 0.01. So the value comes of 0.01 after using this formula. And for KNO3, it is 0.02. This is 0.03 and this is 0.015. Okay. So which is highest? It will be highest for C. Okay. It is highest for what? It is highest for C. So 3 into 0.1. 0.01. So how we are going to calculate? So you are going to put these values. So it is 0.01 into molality. This is number of ions is 2. So same, everything, all. So this after you get this, so you will get second one. So 0.01 into 3. So you will get third one. So 0.015 into 1. You will get 0.015. Understood? Is it clear now? Is it clear now? So I is nothing but what? I is your number of ions. Okay, so we have got. So for urea and glucose, it is 1, 1. And for KNO3, it is 2. And for Na2SO4, it is 3. I is that number of ions. M is what? Molality. Molality is how much? So for first one, it is 0.01 into 1. Okay, so it is 0.01. Then second one, it is 0.01 into 2. So it is 0.02. Third one, it is 0.01 into 3. So it is 0.03. Then fourth one is what? 0.015 into 1. So it is 0.015. So which is highest? It is the third one. Right? Understood now? Okay, fine. Any other difficulty? Yes? Anything else? Everything is clear? So we have solved 12 questions. Okay, so the next remaining questions we'll be discussing in the next class. Okay, fine. So no difficulty, right? Okay, fine. So if you get some more questions, okay, you also go through this chapter of solutions, okay, and try to solve such questions, whatever I have solved today, okay. So similar questions, if you get anywhere, so you can solve those, okay, fine. Okay, so I shall end the session here. We'll be meeting in the next class. Thank you.